Welcome to the DIY Honda Garage channel. DTC P0139 indicates a problem with the rear secondary heated oxygen sensor, specifically with Bank 1, Sensor 2, in the Honda Accord model years 2012 to 2017. This code suggests that the secondary heated oxygen sensor, HO2S, is not responding appropriately, particularly during lean air-fuel ratio conditions. Located downstream of the rear warm-up three-way catalytic converter, the secondary HO2S plays a crucial role in measuring oxygen content in exhaust gases, aiding the powertrain control module, PCM, in controlling the air-fuel ratio for optimal engine performance and emissions control. A malfunction in this sensor can lead to performance issues or increased emissions, triggering a check engine light. Further diagnostics are required to pinpoint the exact cause of the slow response. In the next slides, we will delve deeper into the components involved, possible causes of the issue, symptoms, and comprehensive troubleshooting steps. In conclusion, understanding and addressing DTC P0139 is vital for maintaining the overall performance and efficiency of the Honda Accord from 2012 to 2017. The rear secondary heated oxygen sensor plays a significant role in monitoring exhaust gases and supporting the engine's air-fuel mixture optimization. Failure in this sensor can lead to a range of issues, from poor fuel economy to significant emissions increases, highlighting the need for immediate diagnostics and repair. Prioritizing preventative maintenance ensures that such problems can be minimized, ultimately improving vehicle reliability and driving experience. By understanding the underlying issues related to this DTC and proactive management, Honda Accord owners can enjoy sustained performance and efficiency. The rear secondary heated oxygen sensor, HO2S, located downstream of the rear warm-up three-way catalytic converter, Bank 1, detects the oxygen content in exhaust gases. This sensor is essential for feedback control during stoichiometric air-fuel ratio adjustments, which is crucial for engine efficiency and emissions. The powertrain control module, PCM, utilizes the output voltage from both the rear HO2S and the primary air-fuel ratio sensor, Bank 1. Sensor 1 to optimize the catalytic converter's performance. If the rear secondary HO2S fails to react properly during lean conditions, the PCM perceives this as a malfunction, resulting in a Diagnostic Trouble Code, DTC, being stored. It is vital to address this issue, as ongoing sensor malfunction can escalate into more severe engine performance issues and increased pollutant emissions. Several potential causes for DTC P0139 may lead to the slow response of the rear secondary HO2S. The first potential cause is the deterioration of the sensor itself, which can degrade its ability to provide accurate readings. This could stem from age, contamination, or exposure to extreme conditions. Another major cause could be exhaust system failure, specifically any leaks in the exhaust system, which could result in incorrect readings by the secondary HO2S, as exhaust gases may escape before reaching the sensor. Additionally, issues with electrical connections, such as frayed wires or corrosion, can impair the communication between the sensor and the PCM. It's critical to inspect all potential causes thoroughly to resolve the P0139 error and restore optimal vehicle function. The symptoms associated with DTC P0139 can significantly impact driving experience and vehicle performance. One primary indication of this code is the illumination of the check engine light, MIL. This alert signifies that something is amiss within the vehicle's exhaust sensor system, prompting further investigation. Additionally, drivers may notice poor fuel economy as the engine struggles to maintain an optimal air-fuel mixture due to an unresponsive secondary HO2S. Rough engine performance, characterized by hesitation or stalling, can also manifest if the PCM is unable to adjust fuel delivery correctly. These symptoms, while varying in severity, highlight the urgency of addressing the underlying issue related to DTC P0139. The first step in troubleshooting DTC P0139 involves starting the engine and holding the engine speed at 3,000 RPM without a load. Ensure that the automatic transmission is in park or neutral, or for a manual transmission, place it in neutral. Maintaining this elevated engine speed continues until the radiator fan activates, indicating the engine has reached a certain temperature threshold. This is crucial because the secondary HO2S operates under specific temperature conditions, and starting diagnostics under these conditions assures that the sensor functions correctly. Gaining a comprehensive understanding of engine performance at varied RPMs allows technicians to make informed assessments as they proceed through the troubleshooting process. After successfully holding the engine speed at 3,000 RPM and allowing the radiator fan to primely engage, the next step involves driving the vehicle at a steady speed between 55 and 75 miles per hour for at least 1 minute. This controlled driving condition is essential to simulate normal operating scenarios during which the secondary HO2S is closely monitored by the PCM. Operating consistently in this speed range enables the sensor to adequately respond to exhaust gases under varied conditions, allowing for an authentic evaluation of its function. By maintaining this speed for the required duration, the PCM gathers important data to determine whether the secondary HO2S operates within acceptable parameters, aiding in pinpointing any existing faults. Once the vehicle has been driven at the specified steady speed, the troubleshooting continues with a deceleration phase. The driver must fully close the throttle valve and hold this position for a minimum of 8 seconds. This aspect of testing is crucial because it allows the rear secondary HO2S to respond to lean conditions created by the sudden drop in engine load. Monitoring how the sensor reacts during this deceleration provides vital insights into its responsiveness. If the secondary HO2S fails to react appropriately or remains within a narrow voltage range during this time, it can amplify the suspicion of a malfunction or deterioration of the sensor itself. This process not only aids in confirming the presence of the DTC P0139, but also gives vital clues to resolve it effectively. After completing the necessary repairs and rectifying the issues related to DTC P0139, final verification is essential to confirm successful resolution. Start by clearing the Diagnostic Trouble Codes, DTCs, using an appropriate scan tool. This step is essential as it resets the PCM, allowing the system to run diagnostic tests fresh from the repairs made. Subsequently, a test drive of the vehicle should be undertaken to assess whether the error code reappears. During this drive, it's vital to observe normal vehicle operation behaviors that were previously impacted by the DTC. Successful verification entails not only the absence of the DTC, but also a restoration of smooth engine performance and efficiency, ensuring that all systems operate within designed specifications. Preventive maintenance plays a pivotal role in avoiding issues like DTC P0139 in the future. Regular inspections of the rear secondary heated oxygen sensor are essential, as it allows for early detection of deterioration or damage. Additionally, it is vital to carry out scheduled exhaust system checks to identify any leaks that could impact sensor performance and air-fuel mixture calibration. Maintenance of electrical connections is crucial as well, ensuring that wires are intact and connections are free from corrosion can significantly diminish the risk of such diagnostic trouble codes appearing. Proactively addressing these components contributes to long-term vehicle reliability and optimal performance, ultimately enhancing driving safety and engine efficiency. Please like and subscribe to the channel. See you next time.